Okay, so part two of this shindig. My name is Gautham Narayan. I'm a postdoc at NOAO, and in my spare time, I also run this astronomy on tap to do something, which means I don't actually usually get to speak here about anything. Now, most of our talks that we have at Astronomy on Tap are people talking about their own research. This one is not that. It's going to give you a very broad, big picture view of the science of the planets. And so, none of this is my work. There are literally thousands of people that have to take credit for this talk and every single image that you will see in this talk. Way too many to list over here, but thankfully all of NASA's images are public domain, and so that's okay. You don't have to. What we will be doing though is sort of giving you a little bit of background, like Ben did, about the music, and then stepping you through, like he said, the planets aren't astronomical, they're astrological. So we'll step you through and compare and contrast what we know about the planets astronomically versus how Holst thought about them. So we'll begin with sort of the simple illustration of the solar system, which is got the sun in the middle, the four inner planets, the asteroid belt, and then the outer planets. None of that's to scale. And if we sort of go back to Holst's era, we should first put him in this space and get some context about him. So this is Gustav that you heard about. And like Ben said, he was born in 1874 in Sheffield, England. Holst was very, very sickly as a child. He had neuritis, and so he couldn't really play piano for very, very long. He had asthma, and so his parents thought it was a great idea for him to try to learn trombone. That didn't go so well. And he suffered from what was called benign neglect from his father and his stepmother. So essentially, he was allowed to do his own thing and wasn't particularly a brilliant child, and so was sort of cheating in school. But thankfully, his family was entirely musical, and so put him in touch with a whole bunch of famous composers. And as you heard, he was very, very influenced by Richard Wagner. One of his best friends was Ralph Vaughan Williams, and he had a lot of support from Henry B. Gardner, who eventually actually sponsored the very first performance of the Planets in 1918. So going on, most of his early work in the 1910s sort of were influenced by, for example, India. He wrote a whole bunch of operas, including one on Ramayana and Mahabharata, but they just didn't do very much for the public. And it wasn't until 1913 when he was on a vacation, essentially a recuperation trip to Mallorca in Spain, that he was introduced to astrology. And at that time, like Ben told you, astrology became his pet vice. It became his little hobby, and he would cast friends' horoscopes. Now, my father did casting of horoscopes. He's a scientist. He did this to pick up girls. Holst was much more into this, and he was actually interested in the mythology behind the planets, and of course, used this as his material to start composing this piece, because when he volunteered to fight in World War I, he was turned down. Again, he was very sickly. And so he spent his time in a girls' school where he was the instructor, cooped up, writing the Planet Suite. And let's put this in context of what we knew about the planets in this day and age. So this is sort of an illustration of the planets. It's from this, the transparent solar system, which is from 1875. And this is sort of the 19th century view of the planets, and it's largely correct. It's a little incomplete. Neptune was only discovered in 1846, just a little bit before Holst was born. Pluto isn't known at all at this point of time. We only know about 4 of Jupiter's moons. There's Halley's Comet in there because we think Halley's Comet is important to the solar system body. There's a few other things that you may not even have heard about in school. Most of these are what we call parts of the asteroid belt now. And what really changed our view of the planets was our ability to start building bigger and bigger telescopes. So around the same time, we built the Lick telescope in California. This is the Lick 36-inch refractor. And this lets you get really, really detailed images of the surfaces of planets. And so it really fuels the imagination and lets you sort of think about how the planets are as actual worlds. You can actually still see the Lick refractor today. This is the same telescope in the previous illustration from just a couple of years ago. It's a beautiful, beautiful instrument. You can go out to the University of California and have a look at it. And it's a lovely facility. So this is an image of Mars back in 1875, the year after Holst was born. Doesn't look like much, eh? It's kind of fuzzy. It's got this like black splotch across it. Can't really tell a whole lot about it. This is a map made by a gentleman named Schiaparelli, and it's a map of Mars with different little bits labeled. As it turns out today, the European Space Agency tried to land a spacecraft called Schiaparelli on Mars. They lost contact with it as it was landing, so we're not going to say very much more about that. But they're declaring the mission a success for the time being, and hopefully they will be able to re-establish contact in the next couple of days, and hopefully it will start doing some new science. But it's named for the gentleman who made this map. A little bit closer to home, in Flagstaff, Arizona, Percival Lowell had a pretty big telescope of his own, and he started drawing images of Mars. And if you look at these images that Lowell drew, you'll find like little line features. He thought these were canals. Schiaparelli had talked about canali on Mars. Now, a mistranslation from Italian to English meant that channels, which is what canali means, got translated into canals, and people thought they were actually looking at canals in the form of alien civilizations having built something on Mars. And Lowell became completely convinced that this was the case, and was really determined to find life on Mars. And so that sort of sets up how we think of Mars, even today in some ways, because Mars mythologically was, of course, the bringer of war, like I'd said. It's a red planet, and so it's associated with blood. And in mythology, it's associated with Ares in the Greek mythology and the god Mars in Roman mythology. And so Holst's view of Mars, his astrological view and mythological view, derived from this imagery. And it gets modified, of course, now that we start thinking about canals on Mars with popular science fiction. So now people think of there are princesses on Mars and kingdoms, and so you have all of these classic science fiction books. This one by a guy named Edgar Rice Burroughs, who you might know also wrote Tarzan. And of course, this is from the War of the Worlds. So these are Martian invaders committing war here on Earth, destroying everything, from H.G. Wells. And even today, if you look at the symbol of Mars, it's a circle with a line coming out of it, an arrow coming out of it. It's the shield and spear of Mars in mythology. It's also, of course, the symbol that's used to denote the male sex. And this is, for example, here on a coat of arms of a city in Europe, next to some cannons arrayed. So we really still think about Mars as the bringer of war in this framework. Now, if you actually look at Mars, it doesn't look anything like this. We started having missions to Mars in the 1960s after World War II, and this is the first ones that sort of moved on were the Mariner probes. And that's the very first close-up image of Mars, that rainy little thing in the bottom there. Mariner took only a little bit of data, but it was followed up by a system called Viking. Viking was a lander. So this is the lander sitting next to Carl Sagan, and this lander made it to the surface of Mars. And this is a remarkable achievement in the 60s, and so Viking took some of the first images of Mars, and that's the very first image that we had from the Viking lander of rocks on Mars. This is not a whole distinguished panorama like you see these days, but this is an image from another planet in the 60s. That's freaking cool. So this is just 70s, and it's just a few years after the Apollo missions, which were to the moon. Now, Mars is way farther than the moon, so this is a remarkable distance to have covered in not very much time. Moving further, we had the Mars Global Surveyor, which was a satellite that was put into orbit around Mars, much like we put satellites into orbit around Earth. And you can see features now that are remarkably clear, much more clear than the images that Schiaparelli and Lowell were drawing. That scar across the surface of Mars right in the middle there, that's Via Marineris. It's the deepest canyon in the world. It dwarfs the Grand Canyon in length and depth. But of course, the Global Survey was operational for 4 years, and so it took a whole bunch of data and did a whole bunch of really cool things. One of those things was realizing that there was, in fact, ice on the polar caps of Mars. So this is the southern polar cap of Mars in this animation. And this is all real, honest-to-goodness data from the satellite that has been rendered onto a sphere. And will slowly pan to the northern polar cap of Mars, where you again see ice there. This is a remarkable development in not very much time. Pretty, huh? And where there's ice, of course, you might imagine that there is water. And where there's water, you might imagine that there's people. And so, of course, the big mission for the Mars Global Survey was finding evidence of flowing water on Mars. And there was very, very tentative, not strongly confirmed evidence. You could see things like new deposits on Mars, but because the instrument wasn't available all the time and had pretty poor resolution, this was again in the 1990s, you couldn't really definitively say that this was flowing water on Mars. But it certainly looked that way. Now, the next thing you can do, of course, is if you have a digital camera from 1999 odd, you might remember that it's less than a megapixel, and it probably takes a 3¼ inch floppy disk to work. You can make a much, much better camera today than you could back then, and so people did. And the next big camera that went on is the high-res camera. Now, high-res is super important if you're at the University of Arizona because it's operated out of here. It's operated out of Tucson at the Lunar Planetary Laboratory, and it had a resolution that was 5 times more than anything that the Mars Global Surveyor could do. So it was going to get much, much more detailed images of Mars. And so once it launched, which was, this is again an image of the launch plus a website to go to if you are interested in LPL's data for high-res, it was going to take some stunning images. And what's going to follow is just stunning images. I'm not going to add text. This is surface gradation, layering, like you see in the Grand Canyon here in Arizona, but on Mars. You can see different geological layers stacked on top of each other. This is the effect of wind on Mars, sand dunes blown. You can see the curves there and the different coloring from light to shadow. No, none of these images are exactly true color. They've all had the stretch improved.
You almost never ever see a true color image.
Yeah, there's very little true coloring in this. Again, zooming in on some of those sand dunes, you can see the resolution of this thing. It's just incredible how much more we can see. This is a sand dune surrounded by windswept layers, and you can see how the winds moved across and the patterns it's left on Mars. And of course, where there's wind and moving sand, there are landslides. So this is an image from the Mars Reconnaissance Orbiter of a landslide on another planet. You can see the direction of it. It's a stunning image. And you'll see a lot of this, I hope, at the Tucson Symphony Orchestra concerts on Friday and Sunday. And of course, now you have definitive evidence of water that's actually flowing on Mars. That's very helpfully marked here with the little red arrows. If you look at these images, they're from 2 years apart, and you can see those little black strips marked with the red arrows having increased their length. These are called RSL, or repetitive slope lineae, which is just fancy for something that's a straight line on a slope that repeats over time. And so this was again discovered by a student who was originally at the University of Arizona. This is an image of Mars' moon, Phobos. From Greek mythology, Phobos is Ares' child and rides with him in the chariot, and he's the bringer of destruction and fury. And this is Mars' second moon, Deimos. Both of these are stunning images, and you just could not have gotten these back in the 60s and 70s, and there was no indication of them really back in Lowell's time. And of course, the images from high-res are so good, you can sometimes see features that aren't even sort of what you might expect on Mars. So there's a little black dot there. What do you think that is? Anybody?
The shadow of the scale.
Previous lander is pretty close. It's the Mars Spirit rover. So Mars is the only planet that we have that's inhabited by robots. This is an image of the descent of the Curiosity lander. If you look at the little inset there, you can see Curiosity's parachute opening up as it was lowered onto the surface of Mars. This was just a coincidence that high-res happened to be in the right place and was able to take images of it while it was descending. So you can actually see. Oh, is it Phoenix? Sorry, it's Phoenix. And there's honest to goodness evidence of the rovers on Mars. You can actually, if you look about or a third of the way from the top of that image, you can see tracks. Those are the rover's trails as it moves, and there's a little blue dot all the way on the left of that image. That's the rover itself. And of course, this being the 21st century, our rovers can do all sorts of cool things. This thing has a whole bunch of lasers and laboratories on that for chemical analysis, but of course its biggest feature is that it can take selfies. So this is a lovely selfie of the Mars Curiosity rover, and beautiful panorama around it. And of course, when you have data like this, you can only get better and better results by building better and better rovers. And so you can see within 3 generations, from Sojourner to Spirit and Opportunity to Curiosity, how far we've come and how much more complex the rovers that are currently on Mars are. And this isn't the end. We will be putting more rovers on Mars in the near future. Curiosity has a massive payload of instruments and takes stunning panoramas of Mars. And this has a whole bunch of scientific merit and impact. And there's a whole bunch of people at the University of Arizona, for example, that study these things. But they also have an extra purpose, these images. They're really useful for Hollywood. If you're creating a movie called The Martian, for example, you simply download a whole bunch of images from Curiosity and simply use them to populate your landscape. And so we've come from here, which are these original Mariner mission, to Mars Global Surveyor, to now the Mars Reconnaissance Orbiter, and MAVEN, which is another instrument I'm not going to talk about, but that's important for the UFA, and it's studying the atmosphere and volatile chemicals in Mars. We've talked a little bit about the rovers on Mars, and there's going to be new Mars missions. InSight is going to be launching in 2018, and there will be another rover hopefully in 2020, plus more that's going to go on after that. But of course, why stop with robots, right? Why not just go to Mars? And so NASA is very seriously considering a journey to Mars. Now, it's probably going to be a one-way trip initially, but the entire plan of NASA building its space launch system out and the Orion capsule is to eventually get astronauts to Mars. And NASA isn't the only people thinking about this. This is from Elon Musk's SpaceX organization. This was just within the last month. They announced that they were going to actually build a rocket that was much bigger than the Saturn V, had much more thrust and technical specifications, that was going to be able to carry people to Mars. And they have a vision of how this will look. They have these little pods that will initially be able to land on Mars and then take off again. And eventually they hope to assemble this into some sort of space station on the planet. You can see a little rover in the front there. It's probably not going to end up being accurate because we can already build rovers that are more complicated than that. And so we really are thinking about going to Mars. Far from being a warlike, inhospitable planet that is what you have in mythology, it's probably our best place to settle down after the Earth. It's actually pretty cool. By contrast, this is an image of Venus. And as you heard Ben say earlier, if you see an optical image of Venus, like this one, it's fantastically boring. Because that's about all you see about Venus. It's shrouded in clouds and it looks completely smooth almost. The mythology in Venus is pretty famous as well. Venus is, of course, the morning star. And in Holst's composition, she's called the bringer of peace. Now, why do you think that might be? The Roman deity Venus is, of course, associated with love and beauty. And she's really important because her temple is where the Romans and Sabaeans meet with a myrtle branch and make their peace, which eventually, of course, allows the Roman Empire to start. So she's venerated within Rome, and this is probably why Holst describes her as the bringer of peace. Depictions of Venus still draw from this mythology, and it's not hard to see why. Sandro Botticelli's painting from the 16th century of the birth of Venus here again has her as a fragile creature, espousing love, sort of coming out of the seashell there, and gentle. And you can sort of imagine why this is associated with the planet Venus. So you can imagine why love and brightness and light are associated with the planet Venus, because Venus, if you look at the night sky, is one of the brightest things there is. In fact, apart from the sun and the moon, it is the brightest thing in that image. And you can see the entire Milky Way and all the other stars near it. But you can see Venus shining right in the middle there with this radical light behind it. And so it's, of course, been the source of many famous poems and hymns throughout the ages. Now, our astronomical view of Venus is somewhat different from this romantic notion. We don't actually have all that much data for Venus, and there's a good reason for this. This is actually the very same ultraviolet image of Venus's clouds that Ben had mentioned in his talk. And so if you look at this, all you're looking at is the very cloud cover of Venus. And these clouds aren't just sort of regular water vapor that we get on Earth. Venus is hell. Venus surface temperature is something like 870 Fahrenheit. Lead will flow like liquid. Those clouds aren't water vapor clouds, they're sulfuric acid rain. What Venus was is a classic example of the greenhouse effect completely gone to extremes. It's so hot because all of the moisture that might have been in its prepubescent oceans has evaporated and eventually created a dense cloud cover that trapped heat and heat the planet up. If you look at Venus in topology from the Magellan probe, you actually look at its surface, and people have done this over time and seen that its surface features are actually constantly changing. Things are actually melting and flowing and cooling over time. And so this is a false colored image showing relief. When things are high, when things are low. We've actually had landed probes on Venus. The Soviet Union landed a couple of different Venera probes on their orbits. Several Venera probes actually. But they don't survive very long. The most they've ever survived is a couple of hours, and most of them, on average, survive just a little bit more than 50 minutes. Because the heat's too much, the sulfuric acid rain starts to kill the probes. And of course, Venus, on top of all of this, massive cloud cover, has more lightning storms than on Earth. This is not very good for sensitive electronics, as you might imagine. What's really cool about Venus and what we've learned about within the last 2 days is that Venus might still have active volcanoes. So this is, right now, the reason I'm doing this talk instead of a planetary scientist is because there's the Division of Planetary Science meeting of the American Astronomical Society going on in Pasadena, California. And one of the groups over there put out this news release yesterday. So this is hot off the press science. This is an image of Idun Mons. It's a volcano on Venus, and it's active. They've gotten images over time to show its lava flows, and they've been able to find lava flows from this volcano, and they've highlighted them here. So this is an active planet. It's actually geologically completely active, and this is stunning data that literally came out yesterday. It's hot off the press. Venus, of course, is a real lesson for ourselves here on Earth of what happens when you don't actually proactively deal with climate change. Because once you got a runaway greenhouse effect like it's gotten, while we'll never get as bad as Venus, it does make it an environment that's completely inhospitable for us. And so for now, we have one home, and movies like The Martian remain science fiction. So this odd thing with Holst's composition. The bringer of war is actually probably pretty good for us to potentially go live on, whereas the bringer of peace, Venus, is absolute hell, and you wouldn't want to go anywhere near it. So in the little bit of time I have left, I want to do one more planet that we have. Sadly, the sound wasn't working on it with Ben's talk, otherwise you've actually heard this piece of music as well. But this is again an image of Jupiter from around Holst's time. This is the best data that they had to look at around 1874, and it again looks like a smudge. And you can sort of see some bands there and maybe a little blob off to the top left, but nothing is particularly apparent. And so this is sort of the view that he had to work with, and so instead he sensibly picked the mythology of Jupiter to go on. Jupiter in Roman mythology is the son of Saturn and the brother of Neptune. And he's probably the most important god in all of Roman mythology. His temple is called Jupiter Optimus Maximus, which is also apparently a new Transformers character in the next movie. And he's the god of light in the sky, and he smites whoever the hell he pleases with thunderbolts, and he sleeps with whoever the hell he pleases, much like our current presidential candidates, apparently. And of course, that means that bulls are sacrificed to him for benefit. There are festivals to him. The Ides of every month dedicated to him. If you heard the Ides of March, for example, he's depicted typically with his staff, and his symbol there is the eagle. And so it is essentially the king world. And so our depictions of this world have to take that into account. Holst's idea of Venus was, of course, the king world, and if we look at it astronomically, it's not all that different for us. So if you look at those images of bands, this is from 1890. This is a drawing. This is the best they could do with their glass plates and stuff even at the time. So they were looking through their eyepieces in the telescope at those sort of grainy images that I showed you, and drawing these things out. And so you can see a few spots labeled here. This is by a gentleman named Keeler. And so Jupiter is the best studied planet we have, partly because it is the largest planet in our solar system, and it is easily resolved. And so it has the longest history of observations for us. And even with a small telescope, you can actually see those features and draw them out. And as telescopes got better and better, people got better and better in doing this, and they could actually see features change over time. So here's 4 panels of Jupiter, again drawn out, but you can actually see bands are clearly rotating, that red spot comes into view over time. Its moons are frequently drawn out, and they're all very visible. And Jupiter has much more than the 4 moons that it's typically depicted with. It has a whole lot of 67, as we now know, and a faint ring system to go with it. So Holst's image of Jupiter as the king world in some ways is actually pretty accurate, because if you think about what 67 moons might look like, it looks like this. So Jupiter is itself the king of its own solar system in some sense, or the king of its own planetary system, with a whole bunch of things circling around it all the time. And this isn't all of them. I couldn't actually find orbital elements for some of the smaller ones, so what you see is what you get. But there's a good chunk of moons there, and way more than our own planet or any of the other planets. As we started getting data on Jupiter, the first data set that we had was the Pioneer mission. And Pioneer was a mission that was going towards the outer solar system and was using Jupiter for a gravity slingshot assist. So essentially hurtling towards Jupiter, getting sped up by its gravity, and then shooting out around it towards the outside of the solar system. And so as it did this flyby, it took a sequence of images of the planet. And you can actually see the red spot over there. And as it goes into the dark side, you can see the planet sort of fade away. And so this is spectacular data for its day, but of course we can do quite a lot better than that. And we do a lot better than that with the next generation of spacecraft, which was of course Voyager. And this is Voyager's approach to Jupiter, and you can actually see features evolve. And the red spot, for example, there, circle and move. And it's stunning data even now, several years later. But Voyager, of course, had a color camera, and so you can see things in much higher resolution. So this is the red spot of Jupiter. You can see clouds and all of these incredible effects of different layers of clouds mixing with each other. Just absolutely stunning imagery. Jupiter has aurora, much like Earth. So Jupiter is very heavily magnetic, and on the top there you see an aurora borealis of Jupiter. And what we've been able to do now with the latest spacecraft to Jupiter called Juno, and I'll try to play this before the train comes on. So you should be able to hear aurora. So this is Jupiter's aurora converted through Juno into audio bands. So you're actually listening to the aurora on another planet. The frequency of this thing is pretty amazing. So that's charged particles from the sun smashing against the magnetic field of Jupiter, looping on field lines, smacking into the poles, translated by a spacecraft launched from Earth into audio bands for your listening pleasure before the train gets here. That's pretty damned amazing, if I do say so myself. That was about 13 hours sped up into something that's more comprehensible. The effect of actually shifting those frequencies from the aurora frequencies into audio bands is actually not that different than the train going by us. At the frequency of the train, as you can imagine, its whistle is changing, and we're shifting it much the same way at lower and lower frequencies as it goes away. It's very much the Doppler effect, just applied retrospectively to a sound file. So after Voyager, we had the Galileo probe. And Galileo not only gave us great images of Jupiter, but also images of its moon system. So these are the 4 of Jupiter's big moons. But now, much better than the single dots that you had resolved earlier. It's Io, Callisto, Ganymede, and Europa rendered over here. And of course, our data is even better than this. We can get sort of time lapses. Jupiter is a massive boon to us because it is such a massive planet and has captured so many moons. It's also effectively a deflector shield for the outer solar system. So comets, for example, or asteroids are effectively affected by Jupiter's orbit and therefore don't make it towards Earth. But sometimes those comets in fact get too close to Jupiter, like this one. This is called Shoemaker-Levy, and it splits into a whole bunch of little fragments there. And as you can imagine, what's going to happen is those fragments are all aimed at Jupiter, and so they're going to hit. And when they hit, they leave scars on the planet. The scars on Jupiter's clouds will eventually heal over time. But I'd like to point out something. Those pockmarked clouds, those scars from a comet smashing into the planet, they're bigger than the Earth. This is an image of Io, one of Jupiter's moons on its rings, and you can see the scale here. It just is dwarfed completely by the planet. But Io is itself incredibly active and volcanic. And so the New Horizons spacecraft, as it went towards Pluto, was actually able to image Io, and you could see volcanic plumes shoot out from the top there off this planet as New Horizons sped away. It was also getting a gravity assist from Jupiter. This is now pretty much the standard way to try to reach the outer solar system, is you first make a little stop off at Jupiter to get a boost of speed. This is yet another moon of Jupiter. This is Europa, and if you remember Arthur C. Clarke and his 2001 Space Odyssey series, in one of those books, he remarkably presciently wrote this line saying, "All these worlds are yours except Europa. Attempt no landings there, because potentially Europa might harbor life under its oceans, life in its oceans under its icy surface." So if you look at Europa, you see all of these line structures, and if you look a little bit more closely, these are actually fissures. These are cracks in ice. Underneath this ice sheet, what we really think is going to happen is that there are oceans and potentially life near geothermal vents, much like we have on Earth. And so, very seriously, people are planning a mission to Europa to potentially have a submersible crack under the ice surface and try to look for life in this environment, which is pretty insane. This will almost certainly happen within our lifetimes. And this isn't science fiction, right? So Europa is about the same size as Earth's moon. So you could potentially imagine sometime in the distant future somebody swimming in the oceans of Europa, which would be just incredible, I think. This is a poster that you can download from NASA, the Exoplanet Travel Bureau at NASA, and you can print it out and put it on your wall. It's a pretty amazing thing. If you're here next week for our next edition of Space Class, I'll have some of these to give away. So sort of giving you a quick retrospective of how far we've come. 1879 is just 5 years after Holst's birth, and a couple of years later you can sort of just see how in the intervening time technology has improved our view of this thing substantially, and this is really why we have these space probes and why we're studying space, because we're constantly getting better technology and therefore we can study things better and learn much more about them. Now I don't have time to go through all of the planets in Holst's suite, but what I figured I would do is give you a quick tour of the rest of the worlds of the solar system through these space probes. So here's sort of the Jovian worlds. Jupiter, of course, we talked about, but Saturn, Uranus, and Neptune there. But the very first world in Holst's suite after Mars is, or after Venus, is Mercury, is the messenger. So this is an image of Mercury transiting across the sun. And being the closest planet to the sun, it's the fastest around, which is why you can imagine it's called the messenger in Holst's mythology. It speedily crosses the sky. We have really, really incredible data of Mercury from the not ironically named Messenger space probe. And so this is a false color image of the surface of Mercury from that probe, combining all of its data. And you can look at this world, and it looks nothing like features that we've seen on Earth. It certainly doesn't even look like Mars. It's much more cracked and scarred with craters. It almost looks like some of the moons that we've seen, perhaps even our moon. Saturn, of course, is the bringer of old age, but the ring system on Saturn is incredibly, incredibly young. It's only been around a few 100 million years and won't be around forever. It's an incredibly short-lived system. And if you look at the entire ring system, it's a stunning, stunning thing. Now, if your eyes are really, really good, you might even pick out some dots in this image that are not rings. Sometimes they're not even moons of Saturn here. So if we zoom a little bit, we'll come in on one of these dots there at the 4 o'clock position. So it's off to the lower right, just underneath the rings. Any idea what that might be? That's Earth and the Moon. They're cheating. Astronomers shouldn't cheat. Saturn has some really, really impressive features. Its pole has a hexagonal shaped structure that we don't completely understand the origins of. We don't know how you can get a hexagon in nature easily. It's probably some boundary condition effect, perhaps with its own magnetic field. But how do you have a boundary on a sphere? It's a hard problem to get. And so this is, again, data from an instrument that is studied here in Tucson, the WIMS instrument on the Cassini space probe in Saturn. Cassini's got about another year of its mission left before it's crashed into Saturn's atmosphere. But it should be doing some very, very spectacular science in that time. Going out further and further, Uranus and Neptune. These are almost entirely imaged by the Voyager space probe as it headed out to the solar system. We don't have very good data from anything else. Uranus is sort of interesting because it's tipped over on its side, almost like none of the other planets. And Neptune is almost featureless, but it also has these giant storms, as you can see there, much like Jupiter's great red spot, except these are dark spots. Uranus has a ring system, an incredibly developed ring system. And this isn't Saturn's rings. These are Uranus's rings, just completely, the stretch has been increased very, very, very high. Uranus has some really, really incredible moons. This is Miranda. You can see the surface of this thing has been ripped and scarred and torn, and it's incredibly fractured. And so there's clearly a lot of geological interaction here, potentially between Miranda itself and Uranus, or perhaps Miranda itself is active and has seen lots of numerous collisions in its lifetime. It's been destroyed and reformed in some interesting ways. We won't know until we get another probe out there. This is another great image of Neptune here, and you can see it's got 2 storms. If you look at this thing and close up, there's this great dark spot and a little dark spot near the bottom there. But the thing that's stunning about Neptune is look at those clouds. They're so heavily trailed. The winds are ripping the clouds apart. These are super winds that are stretching clouds across the entire planet. It's really, really nothing like what we've got on Earth here. And of course, we don't have to stop with our own solar system. So the Kepler space probe has been looking for planets around other stars. So Kepler is a mission to go stare at a small patch of sky, no larger than the postal stamp, and it's found thousands and thousands and thousands of planets. If you sort of animate all of them, these are just certain orrery of the worlds that Kepler has found. You can see our own solar system there for scale, but the worlds that we're finding now, they look nothing like our solar system. They're just completely different things. And Kepler has found thousands and thousands and thousands of them. And this is just, again, a small little patch of sky in our own galaxy. So you can stretch your mind potentially to how many stars in our entire galaxy will have planets, and this will simply cover this entire video out there. And this sort of just increases over time and zooms in and out. So we'll end here with a world that's not actually anywhere in Holst's composition. It's our own planet. Earth is not a movement in his piece. Holst, of course, drew his entire composition from these astrological and mythological views of planets, and it is an entirely romantic notion, and there's no science involved, as Ben mentioned. So he took a lot of artistic license, which is great. He created something that was truly unique and creative. But some of the themes that he had totally fit. For example, Jupiter is in fact an incredibly powerful giant world. It is in fact is the bringer of jollity in some ways. It is the all-powerful mythological deity in our solar system, if you are thinking about it in terms of planets. Whereas others don't at all. Venus again is completely inhospitable, versus Mars, which instead of being the god of war, is probably where human beings will first get off our planet. And as we push further and further into the solar system, we learn more and more. We've barely explored our own world, let alone the other planets of our own solar system. So there's a lot more that we can do. All of the worlds, of course, in our galaxy are beyond the widest scheme of any composer. So if there are any of you in the audience, this is great because there's limitless creative potential here, right? If you wanted to create an exoplanet composition, you could just keep adding movements, and you'd never run out of planets. All of these missions together cost less than a single concert ticket. Now, buy a concert ticket. That's cool, and you should totally go see the concert. Any three of those missions together per year per person cost less than a single beer that you bought here. This is why we do science. It's incredibly productive stuff, and we do this because it's not hugely well paying or anything, but we really are learning something, and that's totally worth it, I think. So I'll end there and take any questions you have. Did I stun you all into silence? We'll just assume that you guys are all happy with your beer and what we said about the planets, and we'll leave you to it. We hope to see you back next week. So we'll have yet another spacecraft next week. This one is not actually a global spacecraft. It's in lieu of November having just being a crazy month and having Thanksgiving and such. And so instead of doing November's spacecraft in November, we're doing it at the end of October. So we'll have two scientists. Ed Prather, who's a professor at the University of Arizona, will be talking about his work. And Sarah Sutton will be talking about more on the planet Mars and her work on the planet Mars. So if that sort of stuff is interesting to you, we hope to see you back next week. And thank you all again for coming out tonight. And I think you made a much better choice than this debate. So.